Right, so Nigel has 3 black socks, 4 red socks, and 6 white socks in his sock drawer. He reaches in and pulls out a sock at random. Do you all know what the probability that the sock is white?
6.
Yeah. So we would have, is it going to work? So 6 from 13. Nigel puts the sock back in the drawer. Drawer. Then he pulls out 2 socks at random. Find the probability that the first sock is black, the second sock is red. So this is where people start to get confused, but it will become easy for you. The word in here, the first sock is black and the second sock is red. So what do we do with the word and? Multiply. So what's the probability that the first sock is black? So black is 3. Okay, so we've got 3 from 13. So we're looking for black. Let's go slow. Black and then and red. So the and is the multiply, and then the probability for red is, yeah, so 4 red. Now what's important here is then he pulls out 2 socks at random. Okay, he did put the sock back from before, so that's not impacting, but what's the probability of getting a red? It's 4 from 12 now. Okay, because one of them's gone. All right, so we've got 1 less sock, so we should have to be 12 from
156.
Okay. Yeah, you can write on your papers. I don't need them back now. Okay. Does that make sense?
Yeah.
Nigel then returns the 2 socks. Then once more he pulls out 2 socks at random. Calculate the probability that the 2 socks are the same colour. So we would say the options are, what was it? White and white, or black and black. Now, you wouldn't necessarily need to write all this. I'm just explaining. Or red and red. So how many white socks were there?
6.
So there were 6 when I pulled the first one. There'd only be 5 if I pull out a second one. Black, there is
3.
So 3, but there would only be 2. Red is 4, and then there would only be 3. So we've got 6 from 13 and 5 from 12, or 3 from 13 and 2 from 12, or 4 from 13 and 3 from 12. And what do we do with all those? So we've got each one is 156. And then 6 times 5 is 30, 6 and 12. And what do you do with those answers? The words or mean we add them together. Okay. So we then end up with 30 plus 6 plus 12 all over 156. Okay. Which is 48 from 156. So you'll notice that we've not really used any formulas as such. We have applied those. We've done the probability of A multiplied the probability. I didn't use the formulas. I've not used a tree diagram, but I could have done for this, but I've got the knowledge is there. I could have done a tree diagram, worked out all the possible options. I could have done a two-way table if I'd have preferred. Which they have made possible by doing only two socks. So you could have used whatever method. All right. What size would your two-way table be? Yeah, so if I wanted to do a two-way table to work out the probabilities of these, what would your two-way table look like? And would it agree with this? So 156 as the denominator. Or is there a problem with using a two-way table in this situation? So I'm going to stop recording because this won't look. Okay, so from the top of a vertical cliff, oh, come on, draw. So here's my vertical cliff, is 250 meters above sea level. Here's my sea. Observer receives two ships west of the foot of the cliff. The angles of depression. So when you do angles of depression, remember you're at the top, you look out, and it's how far you look down. So the angles of depression of the ships measure 62. So if I look down like that, that's one ship. So that would be the 62 degrees. And then the other one would be only 34. So that's where it's, oops. So that would be 34 degrees. Okay? Find to the nearest meter the distance of each ship from the foot of the vertical cliff. All right, so you've got options now. Right, you can either use these, but then your triangle would be extended. I'd either do it like here and come down and like this, or you realize that these angles are not the 62 and the 34. All right. So what we have then, so we've got ship A, ship B, right? This is each ship. So if I make this 250 and this 250, so my two triangles basically, if I do that, so I've got one which is 62, this is 34, sorry, 250 meters, and I want to know the distance from the foot. So instead of doing this distance, I'm going to do it up here, same distance, yeah, but I've done it at the top. So that's my x. So what am I using? Got, this is the adjacent side that I'm trying to find. So if I do SOHCAHTOA, the angle that I know is 62 degrees. Okay, the opposite side is 250. The adjacent side is x, and the hypotenuse is don't know, don't care. All right, so I'm going to be using tan. Okay, so tan of 62 equals 250 over x. So then we do x is equal to 250 divided by tan of 62 degrees. Okay. And then the other ship is just the same thing, yeah? So if I do the longer one, so if that's x, then the longer one, let's call it y. So y, I don't even need to redo this. I can go, it's just the tan. Oh, sorry. I'll do that. It's just going to be, again, 250 divided by the tan of 34 degrees. So when we did this, there was a problem. What was the problem you guys had the first time we did it? No, it was at this stage. The problem that you had was actually that you put in these angles in the wrong place. you put them here, didn't you? Rather than you, and then the problem with that is then that the 250 is not the opposite side, it's the adjacent side. So you put it in the wrong place. So this formula here, I think circle, would be the wrong way up. Yeah. What's the other thing to also be aware of with a question that says sine, cosine, tangent with your calculator? Well, that's a processing thing, but it's something you have to be aware of on your calculator. Did you all check? Did you all have your calculators reset or checked?
Yeah.
Did you all check that you put them back on degree mode? Because quite often when you press reset, if a teacher does, when I do it, I go through and I reset and delete things. I always make sure I personally then go into each calculator and make sure it's on degree mode. All right. But you should get into the habit of always checking when, because you never use anything other than degree mode. The other group, potentially, especially at the higher levels, will have to work in radians. So they'll have to get used to swapping. You guys always need to be on degree mode. It only impacts questions with trigonometry, sine, cosine, and tangent. But to have it in degree mode doesn't impact anything else, so you might as well always keep it on degree mode. So, yeah, press your mode button. There, I've got mine. It was on.
Yeah, I was on radio and I had to change it.
So. And that's the problem, I think. Well, if you didn't get to this question, it wasn't going to be an issue. So when I open this thing up, for instance, if I press mode, it always, default setting is this list here on the left. So I'm on degree. So always, before you start, first thing you do before you start anything is make sure you're in degree mode. All right, because again, with this question, if that would have meant your final answers would have been wrong, but if I'd have seen all of this and you'd have had numbers that were a bit unrealistic, hopefully that would have made you think, oh, what's wrong here? If my numbers are like 1 point something and I'm expecting an answer, if that's 250 meters, I'm expecting however a large number, yeah? Not large as in hundreds, thousands, whatever, but if it's 1 point something, you go, radians. That should be a trigger for you. All right. So we've got that, and then write down the distance between the two ships is just subtracting those two answers, yeah? That's it. But that's it. This question specifically, yeah, you're getting the angles in the wrong place. So let's have a look at this then. So a box, diagonal, find AF. All right. I think I remember doing this question. All right. So A to F means you are finding this distance A to F. Yeah. So again, this is just 3D trigonometry, 3D geometry. So what are we going to do? Now, this case, we've got 10, 10. We've got right angle triangle. That's what we're looking for. This shape on the bottom is a right angle triangle. So if I just redraw that, there you go. So 20 and 10, and I want to know this. So hopefully, if there's no angle involved and it's a right angle triangle, you're going to use Pythagoras Theorem. A squared plus b squared is c squared. Okay, so that's 10 squared plus 20 squared equals x squared. So 100 plus 400 square rooted equals x. So we've got x is the square root of 500. Okay, which is 22.4. Okay. Now, my tip for these, I remember I would have said this at the time, is that's good for your final answer. Remember, we should have centimetres. But keep this one in mind, the square root one. Okay? So then the next question is find A to G. So A to G, okay, but it is going up there to there. Now, do we have another triangle? Yes, we do. All right. So I know the height of my triangle. So this is I'm going to say it's the square root of 500. This is then 15, and I want to know, should I call that y? Okay. So I'm going to redraw my triangle. Always a nice tip to do. So what did I say? This one was the square root of 500. That's y. The height was 15. Again, the reason why I've left it as the square root of 500 is because I'm going to do Pythagoras' theorem again. So I'm going to do a squared plus b squared is c squared. So that's 15 squared plus the square root of 500 squared. So I could have used the 22.4. No problem if you did. Ideally, though, I do that because 15 squared is 225, but the square root of 500 squared is 500. That makes it nice, just to work. And then I'm going to do the square root of all that to find c. So then c is the square root of 775, which you can then do on your calculator as
27.8.
27.8. Okay, centimeters. And then we could just check it should be a bit longer than the other one, and it is. It's fine. Okay. Now the tough question. Calculate the angle AG and the base of the box. So where is that? So AG is the line you've just worked out. The base of the box is the other line that you've just worked out. Okay, so it's this angle in here. That's the angle I'm being asked. So actually, we're back to this same triangle as before. Okay, and we've got lots of options now because this is the angle I want. This we've said is 27.8. I'm going to write that decimal this time. And this was what, 22.4? And this one is 15. Okay? And it's a right angle triangle. So I can use, if I do SOHCAHTOA, right, theta is x, opposite is 15, adjacent is 22.4, hypotenuse is, so which one do I use? Any of them. Yeah, pick any of them, all right? What I would suggest is based on potentially you might have made a mistake, limit it by trying to use the one with the number they've given you. So I'm going to use one with the opposite. So I'm either going to use sine or tan, whichever one you think works for you. And yeah, it doesn't matter, does it? So if we did sine of x equals opposite over hypotenuse, so 15 divided by 27.8. And so x would be, how do you get from this point to know what the angle would be? We do the inverse sine, if you remember, of 15 divided by 27.8. So on your calculator, have I got mine open? Should do, haven't I? Why is it not showing me? Okay. So on your calculator, hopefully you're good with this now. We just do second function and sine, and then put 15 divided by 27.8, and I get the answer 0.5699. You happy with that as an answer for the angle? No, you don't get that. Yeah, that sounds better for an angle. I've got half a degree. What have I done wrong? It's in radians. That's what happens. So I would look at that number and go, oh, that does not look like an appropriate answer. So check, because I've had to reopen mine, it's gone back to radians. So if I go to degree, okay, if I do the same thing I just did, sine to minus 1 of 15 divided by 27.8, I get 32.65. degrees. All right. Seem reasonable?
No.
Yeah. Should we move on to paper 2?
Yeah.
Reason with paper 2 is so apart from, I've changed it now, by the way, it says 5. I did it 55 like I said, but you good with this? I think generally use your calculator or just add it up together or whatever. The ones I wanted to focus on, okay, what was the problem, two of you, with the seeing what this looked like on your calculator? Why didn't it work?
I don't know.
So, hey?
I put it in like 6 times. I was really confused.
Well, this is where we've got to practice on our calculator. All right, so you always make sure you do it when we're going through these things. So I'm going to put y equals in, and I'm just going to put that in. So we do 3x squared minus, use your buttons for putting fractions in. Use it as there. 4 divided by x. Put a window in, -5 to 5 for x. Because again, a couple of our questions we forgot to worry about that. It doesn't tell me how to do the y, so I'm just going to press graph to start with. Okay, so I've got that. All right, sketch the graph, indicate clearly any axis intercepts. So really, maybe I just go, let's go up to 20 on the y. There you go. So should look something like that.
Yeah.
So remember, really, ideally, what we should be picking on is I actually need to see the points for -5 and 5, what the coordinates are. How do you find those? Yeah, you could do that. Second calc can do that. There's lots of options. I'm going to go second and graph for table. And in table as well, there's another option. So I can go -5 is the 379 divided by 5. You can turn it into a decimal. And then positive. There's another way to do it. All right? 371 divided by 5. The minimum a bit different because obviously I need to actually figure out the minimum, and that is second and calc for the minimum, yeah? Mm-hmm. It says any asymptotes. So how do I find the asymptote? Now it's clearly down the middle. Yeah. So how can I just confirm that that is down the middle? Yeah. Yeah, exactly. That's just exactly what I'm saying. So when x equals 0, there's an error. You did y, yeah. Shame, because that was a real kind of everything was looking so good, and then you just got that the wrong way around. So when x equals 0, there's an error. So the asymptote is at x equals 0. All right, but yeah, perfect method what you were talking about there. All right, so really, just find our axis intercepts and that kind of stuff, maximum, minimum. So it's just about putting it into your calculator, right? So I don't know what was pressure of the situation or whatever, or, you know, yeah. And then 5x plus 20, again, draw the graph. What about, so actually if I put that in there, so if I put in another y equals and just put 5x plus 20, graph it, you'll see that it crosses. All right, so it says find the solutions to that equals 0. So there's two ways to do it. What would you do with that? Because so far, what we have are two equations. We have f of x is actually 3x squared minus 4x. And we have g of x is 5x plus 20. Oh, let's restart my computer. 5x plus 20, but this is neither of those. But do you spot what it is?
No.
It is. Yeah, it starts here. Now, basically, look at, notice that's negative 5x and negative 20, where this is positive, positive. Now, the reason is because what they've done there is they've said that it's when 3x squared minus 4x is equal to 5x plus 20. So if you rearrange this, yeah, I don't know which bit you're following, the arrow or the pink dot, you get this, yeah? So if I subtract the 5x, subtract the 20. So there's now two options to solve this. I can either use my calculator and just find where they equal, and that's where they cross. All right? So where they intersect. There is another option, though. If I didn't get that, what could I do? If I didn't make the link between them, I could actually just go there, exam tip, just switch them off, just in case I want to come back to them. All right? And then put this one in on its own merits. All right? So I could just put 3x squared, do minus, put my fraction in again, 4 over x, and then subtract 5x, and then subtract 20. If I put that graph, it still fits, right? And where does it equal 0? Where it crosses the axes, yeah? And if you then go to calc and you're looking for the zeros, and you need to find all three of them, all right? And you'll notice that if I went back to and switch those back on, if I have them all in one screen, look, where that line said, where this straight line, where 5x plus 20 crosses this bit, it's at the same point as where this other one is equal to 0. Same up here, look. All right? Now, what they're testing you on is, did you spot that there's a third one up here somewhere that's not on our screen at the moment? There should be 3 answers. So quite often people see the 2, but don't spot the third. Now, if I've done it the other way, look, I've got 1 there, got 1 there, but you'll also then see we've got 1 over here that equals 0. But there are 2 options to do this question. You either realize what it's been asking you for parts A, B, C, D, or you do it as a standalone separate question. All right? Make sense? Mm-hmm. Now, part F will be slightly trickier if you didn't make the link. All right? because part f is saying where is g of x greater than f of x. So on your calculator, if I switch off that, the third option I did, switch this one off. So now I'm after where is the straight line, being the g of x bit, above f of x, the curve. And it's only really between those 2 points and then after the axis until that other point, yeah? So that's what we're looking for. Now, I won't go through working all that out now. I think this is a kind of question we can do all in one go, yeah? But that's basically the process. But do you see how important your calculator is for that? Yeah? It's important that you get into the habit of practicing and using it and knowing it's there. All right. I wanted to go, there's another one just for using your calculator. But the one I wanted to go through is a big question, that one. This is what we need to get you really working on, these lines one, because they're actually easy, but you girls are not managing to get them just yet. They'll be easy marks eventually. But let's have a look at this one. Gave you this one, I thought it'd be nice. chi-squared. I can't believe you didn't get the first one. Write down the null hypothesis. Do you remember I said it's the easiest mark you're going to get in the test? What is it? Null hypothesis. Do you remember what a chi-squared test is actually? What's its full name? Chi-squared test of independence. So the null hypothesis is always blah, 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 and blah, blah, blah are independent. Computer's getting slow. So in this case, it would be choice of sport and age are independent. Yeah? However you choose to write that, choice of sport or activity or whatever, and age group, age or whatever you chose, but the important thing is to say are independent. Yeah? Okay, it's happy enough. Degrees of freedom tend to be all right, yeah? How did you manage it? What did you do? Just put it into your calculator first? And, yeah? Yeah. Yeah, it gives you it. Perfect. If I didn't want to do that, basically, do you remember that degrees of freedom is rows minus 1 multiplied by columns minus 1? So if we look at that, it's just 4 minus 1 is 3, 3 minus 1 is 2, 3 times 2 is 6. So that would be 6. Right. This one, show that the I felt sorry for you, Lily, because you rewrote the table. I was like, show that. Yeah, this is where they get to you in terms. I mean, it's only what, 1 mark or is it 2 marks? But you can't just write the answer down because they've told you the answer. The answer is 17.7. You have to show it. So do you remember how we did it? 26 to 40-year-olds, so 17.7. Show that the expected number before snowboarding. So we are looking for snowboarding, this number here, yeah? Okay, so what do we do? This number divided by this number, multiplied by this number, divided by this number, times this number. I'm doing that, so that's how I would show it. All right. No. All right. And I think actually with the rest of that question, The only thing that you did wrong was your interpretation of the p-value, right? So you had 1.27 or something, yeah? But then it was times 10 to the power of negative 7, which is actually 0.000000127. All right. So you got confused with the fact that it said E negative 7, calculator notation. It's definitely not 1.27, it's 0. Therefore, that then led you to the wrong conclusion because P was actually less than. So we should have rejected the null hypothesis, not accepted it. But you both did the same for that. All right. And that was purely a not knowing the times 10 to the power negative 7 thing. Right, yeah. We'll go through some more next lesson, but then we'll want to move on. Okay. So maybe if you can pick out some questions that you think those are the ones you really want to